There, I believe we are online here. There, I believe we're in line. We're online here, and we're ready to go. You should be able to get to the Q&A, and so I can take questions here. Since we're on a broadcast, I won't necessarily be able to see you, but I can read the questions, and I'll try and read them, and we should be able to get to everything. I'm not sure if everybody got the notifications. For some reason, the last 2 days, I've not been getting the text notifications from D2L for anything that goes on the news feed or anything for that matter. So I don't know if that's the case with you. But I've been putting stuff up, and that's why I emailed out tonight. Tonight, what I'd like to do is I'm just going to screen share here something for a moment. Should be able to see this. The study guide, similar to what we did in class the other day. I think most people seem to be at that. There are a couple of things I want to go through. And then the other thing is that I put up a copy of the mini requirements document that some of the questions we'll be dealing with. About 2/3 of the questions have to do with that. That way, if you want to read it ahead of time and just sort of be used to it, or if if you're like me and a slow reader, it's handy. But there should be adequate time during the test if you haven't read it already, and that's posted under Final. So that's week 16 under D2L. If you can't get to that, or for some reason don't have access to that, let me know and I can email it to you. Let's see. So what I'd like to do is to hit some highlights tonight. If there are questions along the way, I'll stop and do those. But if not, I'm going to go through basically what I know. There's a lot of reading, and several people have mentioned, wow, I can't go back and reread all of that stuff. That is true. But what I'd like to do is tonight go over the things that I think are going to be important. It's not a guarantee that it would be on the test, but if you have good feeling for this, you should be in pretty good shape. A lot of what we've done is not terribly quantitative. It's not like, the answer is 6 or, that you can always do a perfect multiple choice. A lot of these are sort of give me your best answer, and that's how you'll be graded. Was it thoughtful? Did you apparently have the right idea behind this? Remember that this course is about about engineering software, and that involves the development activities and the development management processes that go along with it, and that together constitutes our software engineering process. It's handy to use that 4+1 view of architecture as a mental guide for what's going on at what points in this, and most importantly, the fact that the use case drives so much of this. Because what that really does is it allows us to reconcile the entire process, if you will, around these functional requirements. Let me just get back to my thing. So it's handy to sort of have in your mind that that 4+1 view, because it helps guide you through the process and a lot of the decisions that are being made. So we started out this semester talking about what that engineering process looks like, what the individual activities within them are. For example, requirements modeling, design activities, testing, creating a test model, creating test cases, the project management, configuration management, version control, those kinds of things. And those are straight off the slides that we saw right at the beginning and from chapter 1 in the textbook. We spent some time on UML modeling, and the reason I focus on that is it's less about the fact that you need to know all the little details of the diagram, because that's really important. What it does is each of those things in those diagrams are there for a reason, because it's stuff we need to consider as part of the software engineering activity. It's not because people have to be super great artists with those. That's why we have tools like Glyphy and all of the advanced modeling tools. It's so that we understand what it is we're trying to specify. So you'll need to know the use case diagram well, including the notion of actors, boundaries, system boundary, the use case icon, the oval, naming a use case, and then a use case description if one were asked of you. When somebody asks you to give them a domain model, what concepts exist in the domain, and an object model being what are the associations between all of the different objects in the system and what classes they belong to. The different types of associations we looked at, which were generalization, specialization, for doing inheritance, for example, or and then remember, inheritance is a implementation issue, whereas generalization, specialization allows you to organize classes in terms of their taxonomy. We looked at object diagrams. Remember, objects are instances of classes, and it allowed us to see the structure of a given system, and then a communication diagram, which showed us the communication between those, and packages allowing us to organize those. So that allows us to express a lot of these other things in there. And I think we've gone through enough of these throughout the semester. It should be pretty familiar, and you should be able to generate your own. We sprinkled throughout the concepts of the notion of iterative development, and in particular, what we said was we're going to have this sort of reference model of iterative development, where we go through the software engineering process on a repeated basis, and we talked about that in a generalized way, and then we also talked about it from specifically a Scrum Agile development activity. And so if I were to say to you, well, here's a general project that I want you to build, and assuming you had reasonably detailed requirements, what would the iteration plan look like for a project like that? And assuming that there aren't a lot of changes to the requirements, what would be a reasonable ordering of how you'd put that project together? In the requirements activity, because what it did was it allowed us to examine functional requirements by looking at a number of scenarios and generalizing them into the use cases. It allowed us to decide who the actors were. It allowed us to decide where that system boundary was and what the interaction between the actors and the boundary were. And the reason that's important helps us identify boundary objects. And we had this general division of labor between boundary style objects, controlling style objects, and entity. And the reason we make that top level distinction is, first of all, most objects tend to fall in one of those categories. And later on, we're going to see that they have, later on in our design activity, we're going to see that most objects fall into those categories, and entity objects tend to become database or persistent objects. Controller objects tend to have a lot of state. Boundary objects tend to involve user interface or interfaces to other systems where we need to encode and decode data so that it can move beyond the boundaries. So that top level organization, or discrimination, is very handy. It then gave us the ability to look at functional versus non-functional requirements And non-functional requirements tend to drive a lot of the architectural issues. Architectural issues such as performance. Can I get enough speed? And do I get speed and reliability by having larger scale? In other words, more nodes that can do the same activity, a particular type of hardware that's super fast or has lots of memory. In other words, performance issues. Scalability says, how can I get this so that I can take the services offered by my system and make sure that lots of clients of those services can access it? In other words, can I handle the volume of data or connections appropriately? Non-functional issues might be like security. How easy is it to get in the system? Or do I do identification and authentication? And we saw a list of those different non-functional requirements. Let's see. I'm talking through this pretty fast just to make sure that we're hitting the right ones. In terms of testing, I spend a lot of time making this emphasis between test plans and test cases. And we saw a little bit of that in the midterm, and I think it's important to reemphasize that, where we're thinking about what kinds of, if we're planning tests, it's what features are we testing? How do we intend to go about it to show that, in fact, we are validating that feature? And test cases are specifically designed to do those tests. So test plans, in addition to involving a number of test cases, also tell me what software do I need around, who do I need it, when does it have to be done, what constitutes acceptance. And we looked at black box and white box testing and boundary value analysis. In particular, we tend to try and generate test cases that will test each of my different groups of equivalence class data, meaning I'm going to test things that are in the middle and the edges, like we talked about in class. It's worth going back and looking at the distinction between test plans and test cases. Domain models useful because what it does is it captures the abstractions and the relationships that exist in the domain, and our analysis model then will start to tell us, how do I represent the problem in that same space using classes and associations, and then specific scenarios that show the interactions between them. And that's what our use cases are for. They'll allow us to say, okay, here's a group of scenarios that all support this behavior. I mean, this interaction that supports some value-added behavior. And as we start to look at those and we start to understand what a possible solution might be, as we talked about the other day, we start to think about different patterns that we might have seen before, and they suggest different design patterns, such as command pattern and memento, which is a simple form of persistency. Model view controller pattern is a very important one. And one of the things that's, I think, important to know here is that MVC, or model view controller, can exist at different layers of abstraction. I can do it as a relatively low-level design pattern, button that has a view of the button and a controller for the button and whatever state machine that models the button. Or model view controller can happen at a relatively high level, like we saw with the notion of boundary objects, entity objects, and controller objects. And they all take almost exactly the roles that you would think they do, which is entity objects tend to be the model objects, boundary objects tend to be the view objects, and controller objects tend to be the controller objects. And we see that systems divide up like that. And in fact, one of the classic business systems architectures is database layer, business logic layer, and presentation layer, which is the database layer being the model layer, the business logic layer being the controller layer, and then the presentation logic being the boundary objects. The publish, subscribe, and observer pattern we saw are very common wherever the state of one object changes and others have to be notified. Then we in fact see that as a sub pattern within the model view controller pattern, which is every time the model views, the model changes, it lets all of the different views know so they can update themselves if they want to. Let's see. Are we moving at the right pace? Somebody put a yay or a nay up there just to make sure that I know we're going at the right rate here. Let's see. You should be able to see the outline that we had in class the other day. I don't know if that was up before. It looked like it had flipped back to not sharing. Screen sharing. Yeah. Okay. Let's see. Oh, under issues of software architecture, we talked a little bit about the definition for it, and then the notion of coupling and cohesion. We talked about layering and partitioning, which are two architectural patterns for how we can deal with complexity. There's actually quite a few, but our class wasn't really all about architecture, but those are two important architectural patterns there that you'd want to know. And then we talked about interfaces quite a bit and designing to interfaces, and that we use interfaces as our definition of a contract between a client and the one providing the services. And we started to generalize the notion of services, which is that an object or group of objects can provide a number of abstract services that are of value to clients, and that the interface determines exactly how I engage that object. And the interface itself may stay the same, but the implementations behind them may change. And that the contract between two objects involving that interface will clearly specify what the expected role of each side, the client and the server, the one providing the services, is. As part of going forward to some other classes, in this class we go over the notion of HTML, CSS, and XML and JSON as sort of three stages of exchanging data. We saw that XML and JSON are two ways of formatting data so that it can be transferred between different programs, different processes. It's relatively persistent, so it's handy for data exchange. And in particular, XML and JSON are self-documenting. In other words, we label what the data is. HTML is specifically for arranging the data, in other words, organizing it, such as into a document or into a page or something. And then CSS is responsible for tagging it and allowing us to add properties to the HTML, the organized data. And in particular, we use it as a way of rendering pages and web pages. There's actually bunch of other things you can use it for formatting it for other things, but we won't go in there. Oops, let me just get back there. There we are. So you'll want to know that relationship. XML tags and defines the data. HTML organizes data. CSS allows us to format and otherwise attach properties to it. So it's those three different things. At one point, HTML had gotten very muddied, and there was a lot of data typing in there, and there was all these tags for different formatting, and it gotten very messy. And that's when everybody said, "Whoa, wait, getting way too complicated. Let's split this up into the three different parts." States and state machines, you should be able to do a straightforward state machine, nothing like really complicated with histories and stuff, but you should know initial state, final state, remember that initial state being the black dot, and I can let's see, I think I can get that up. The black dot, and the final state being the black dot with a circle around it. State transitions then is, let's see, I'm just getting back to my Adobe document. There we go. And then transitions, the actual transition from one state to another, and the event that causes it. And that should be adequate for what you need to know. So, for example, if you go back and study the garage door example that we did in class, and sort of understand the beginning and the end states, what the transitions did, why they occurred, and that notion of having those transitory states like stopping and opening, opening and closing, that would be handy to know. Configuration management and change management. Configuration management, you want to know what the items are. In other words, when I assemble a given system, what specific parts, in other words, what's the parts list for that particular build, and each item that's in that configuration may have more than one version. That's why I think the way it's completely wonkish the way he uses the UML to describe all these different things, but in this case, it's very handy. Any configuration item, CI as they call it, any configurable item can have one or more versions to it, and the versions have some numbering or naming strategy. They can be sequential numbers, they can be a set of names, like Android has kind of names like ice cream and lollipop and all these different build names. But in reality, you're thinking of a sequential, usually chronological sequence of releases, which is a release is a promoted item that has become a candidate for release and is released to the client or to the consumer. And so when we version things, we are saying at a certain point, I have applied a set of changes to a current version and promoted that version to the next version. So there may be a number of changes that go on. For example, if you start out with a source code module and you change 7 different lines in it, and then commit those changes, or say, yes, I'm going to now promote this module to the next one, that's the new version, even though there may be more than one change in it. Subsequently, when I build a system, I may select a number of different items to build that, assemble the pieces, And I may say, give me all the current versions, or I may be very specific and say, for this particular build, I want version 3.1 here and 3.1 over here, but version 12.6 of this one and version 11.0 of this one. So you can be very specific about those. So you'll want to know the difference between versioning and configuration management. Configuration management is what things am I what elements am I actually managing? What are their relationships to each other? For example, a build of my system may involve executables, some libraries, a bunch of source code, some documentation, some licenses, and maybe some installation tools and some test tools that all come together to constitute that build. So that configuration may be quite large. I may have a number of versions of each of those things in that. So a question comes up, how would the 4+1 view relate to configuration management? That's actually a great question, because if you look in the logical part of the system, you say, well, these are all the sort of the logical items. But as I start to actually build my system, and I go over to sort of the upper right in the version that I always show, the upper right, which is the development process, I'm starting to think about, well, what things do I actually have to build in order to support those logical requirements for the system? In other words, am I going to build it all as one giant application, one giant executable? Will I build it as several different components that are going to be linked at runtime? And then when I deploy it, which modules what do I actually have to package up to deploy it? For example, when I deploy something, let's say I deploy a Java application, I may say I'm going to include the Java virtual machine with this application just in case the user doesn't have it. And so down at the deployment view, we'd say, well, what do I actually need to package up to deliver this software? You know, we often tend to think, oh, well, I just do the build and, you know, I rebuild it and I execute the main program. That would be the easy way. But it may be like we did with our chrono timer. We actually had to build two different things, didn't we? We built the chrono timer application and we built the web server application, and we had to install and run those separately. So my configuration for the system as a whole actually involved a number of parts. Then over in the process view, that's really more concerned about the threads and the processes and the scaling. So really your question has mostly to do with the development view and that deployment view. What things am I building and what versions do they go through? Does that answer the question? Let's see. Refactoring, you don't need to worry about that. But let's talk about services and components for a bit. You know, we wrapped up a lot, we sort of brought a lot of stuff together when we talked about components, and that's one of the reasons I saved that sort of to the end, because we now have a lot of concepts in our toolkit in order to make the notion of assembling a larger system out of parts. So a component, and you'll want to remember the definition of a component, which is a independently deployable unit that can be used without modification within the context of some messaging model. And so, for example, if we had several different components that were all executing within our operating system, like servlets, for example, They provide a set of services, and those services can be linked together by messaging. And the set of services are defined by the interfaces that they support. And so what you'll want to know is how to represent the interfaces on a component and show that another component depends on that interface. Remember, it's the little ball and socket or the lollipop and the half moon that we saw. So if you want to go back and reference the component architectures there, that's handy. And know the UML notation for that. And so when we start to think about our deployment view, that's really what's going on there. We're thinking about what components do I actually need to put in place and get installed so that when they run, the other services that they're dependent on are there and ready to use. So when we talked about service-oriented architectures, we talked about a range of architectures that allowed us to be very effective engineers, because it allowed us to package up services and software that were reasonably standalone and link them together to create a larger system. And we use the notion of building blocks or Lego blocks to show this assembly of a larger part of a system. And so that's why we sort of hold off in talking about it until the end, because now we have the notion of interfaces, the more formal definition. We have the notion of actually partitioning the system out. Remember, partitioning as an architectural pattern was, we're going to take a given layer and break it into smaller parts so that they're more manageable and that we can make changes to one without affecting others. And then we also talked about layering, which is I can provide services at different layers and link them together. So once we had all those formal concepts in place, we could go back and talk about a service-oriented architecture. And we used as an example the travel-related site, where you had the car rental and the hotel rental, and we had two different car rental services, I think, and we were able to link those components together to form this larger travel system. Let's see, I want to just take a quick look at a couple other things here. Talked about versioning, relationship between configuration items and versioning. From project management perspective, I almost forgot about project management. As far as project management goes, the main thing that we took away from that, there was quite a bit in there, and there's a lot on more traditional project management, which for the most part we did not worry about. What I want you to take away from that is the concept of the fact that there are tasks and activities, tasks being the smallest unit, activities being groups of tasks, and those together represent work. And those allow us to then focus on, I'm just going to pull up one thing. Under project management, when we talked about that, we had tasks and activities, which were types of work, and that activities could be made up of tasks. And the reason we did that was, at some point, we were looking to do that work to generate some work product. And you could have sets of work products that together formed an outcome. And those would at some point be a deliverable, such as it might be something like a requirements document, but it could also be a source code module. It could be the actual executable itself that you were building, whatever the item might be. could be a test plan, could be the actual delivered code, for example. So you had work products that are built by applying activities and tasks, tasks being the smallest unit, activities being the larger ones. And the reason that we worry about that so much is, as an engineer, we have to get very good at trying to predict how long it will take to build our system so we can budget it within our constraints, especially as we get to larger systems. And so we'll need to be able to decompose the work that we have to do into small enough units that we can, first of all, allocate it to our resources, whether it's people, usually people, and that I can decompose the work products into small enough units that I can identify which ones need to be built by who and how long it's going to take. So you'll want to know the notion of work products and sets of work products that provide that constitute an outcome, and that you do that by executing tasks, which can be grouped together into activities, so the difference between activities and tasks is reasonably important there, as important as all of this is. Let's see, I'm going to look at two other things. Just got some notes here. Under testing, you'll probably want to know about test rigs and proxies. Remember when we were talking about testing, we talked about the notion of creating scaffolding, and you could have stub objects that acted like other objects that you don't have the full implementation of, but they were simply stubs that gave the appearance of interacting with it for testing purposes. So that notion of basically that scaffolding that involved your test data, the actual component under test, any stubs or proxy objects that were needed, and then any setup code that went along with it. So almost forgot that. Test cases we talked about, test models we talked about. And then final thing, sprint planning. We talked about that sort of in two different places. We talked about that near the beginning when we talked about iteration plans, and that's where I sort of purposely introduced it at sort of a high level, which said, look, we're going to do these 4 different iterations or sprints, and we're going to allocate the work to those. And then later on, we went back and sort of formalized it in the notion of Scrum, Agile development. But the idea that given a particular project, you'd be able to identify, gee, what are the high-risk mechanisms that I need? And, I need to implement. What's a reasonable set of things that I can deliver over time, over a series of sprints? And at each point, at the end of a sprint, I should have a viable product that I could potentially show or demo to my customer. So, we sort of learned how to do that over the course of the semester in the project. In each sprint, we got a little bit better at it. But now if I were to ask you, I give you a requirement, you can say, a set of requirements, you can go and say, okay, here's basically how I'd lay this out in terms of the iterations that I would deliver. And of course, that's quite subjective, but what I want you to be able to show me is, oh yeah, I'm thinking about what's the riskiest thing, what parts do I need in place first, what can I add on later on, and the fact that you're able to partition it into these separately deliverable sprints. Remember that the test is 2 hours tomorrow from 10 to 12, not just 1 hour. So you should have plenty of time to read through the requirements if you haven't already, and then to sort of stop and think through them. It's important to write legibly because it allows us to be a lot more generous in our interpretation of your answer if we can read it. And then, basically work through it. There's blank, each page has a blank page behind it, so there's plenty of scratch paper. Think through the answers, and you should have more than enough time to complete it fully and with thought if you've gone through the stuff that we've talked about. Let's see. I think the only stuff that is not in the book was a little bit of the stuff on HTML and CSS and a little bit on the services. Other than that, you should have quite a bit of background in the book, but basically using the material from the class as your emphasis. That's what we want to know, and from these reviews. Let's see. I think that's about it. And so if people have questions, the easiest way is with the Q&A component to the side there. And now that we've run through that, if there's anything in particular that either wasn't clear from that, or sort of, how deep you need to know something, I can handle that. I'm going to give you a little pause. The question here is there going to be much multiple choice? It's going to be more short answer and drawing some diagrams. There's no actual multiple choice on it, but there's a number of shorter answer questions. It's divided up into 100 points, and with most of the questions being 5-point questions, a few being 10-point questions. But you have lots of opportunity within those larger ones. So it gives you the opportunity to sort of show me your synthetic knowledge that you can put together the concepts that we've talked about. So I'm going to have you draw some UML diagrams, because that allows, that's a nice shorthanded way of showing me a bunch of different things if you can do those. And then there's some questions on short, 1 or 2 sentence explanations of things and that kind of stuff. For a lot of people, that actually works out better, because they go, boy, if I miss the multiple choice one, I've got it either wrong or right. At least this way I have a chance to get some partial credit on it. What I'm looking for is to show that you've got, what level of knowledge of this area do you have, and can we sort of synthesize it into this larger software engineering process? Not quite as bad as comparative literature, but getting up there. Let's see, I'm just going to scoot back here a little bit. Yeah, basically, if you have a good feel for the stuff on here, you'll do very well. For definition of software architecture, we're just using the straightforward definition of that we talked about in class, which is the parts of the system, how they're related and how they interact, and that's adequate. In architecture, what we're really doing is we're starting to think about decomposing the system into the individual parts so that we can, first of all, manage the complexity of the system, and it allows us to address issues of performance or reliability or security. For example, if I can decompose it in a way that certain elements can be scaled easily, for example, user management or user login stuff, then I can scale that up. Or for security purposes, I may say, for example, a very common one is when mail is delivered to your email server, it doesn't go directly to the email server. It comes into an area where it's scrubbed for malware, and basically it's all staged in one area, and then the email server pulls mail out of that mail bag and brings it into the server for processing and delivery to individuals. That gives me a level of security and a level of reliability and redundancy, even though it doesn't change the logical processing of the system itself. Make sure you bring a pencil and or a pen to write with. Invariably, somebody shows up without one or the other, and I'll have a few, but you'll want to make sure you have something to write with. I think that's about it. Well, if there aren't other questions, I'm going to leave that there. I'll try and monitor my email tonight or texts, and if something comes up, give me a holler. Otherwise, we'll see you at 10 o'clock in the lecture hall tomorrow morning.